there's a huge amount of skills we use in our role. First and foremost, problem solving, critical thinking, hugely important with pretty much everything we do. Not just within biomechanics, but I think that goes for just about any science discipline, really. If you can't problem solve and be a good critical thinker, it's very hard to be a good scientist. So that's really important to us. So we're constantly analysing the way we do things and trying to iterate on that and make it better. Outside of that, there's sort of a lot of other skills I think are really important, particularly when you're feeding back sometimes quite complex information to other people outside of your discipline. So having good presentation skills and good communication skills is really important to us. Being able to analyze data well is hugely important, particularly in biomechanics, but I think across the sports science disciplines. And then there's some more specific technical skills that we also have to build, which kind of assist in our ability to be good biomechanists. So things like being able to code in a few different types of languages, having an understanding of electronics and computers and other technologies that are kind of tangential to biomechanics is super important as well.
So basically, apart from biomechanics, there's sort of critical problem solving that we use quite regularly, and it's sort of embedded into everything we do, trying to answer questions for coaches, which kind of leads you to a variety of different skills that you I end up applying or using. So spend a lot of time doing programming in a variety of different coding languages, and then sort of end up in spaces like CAD packages and electronics packages to develop different solutions that can help us improve our processes and feedback to coaches and athletes.
I'm very fortunate being part of the National Institute Network system that I'm able to work with a lot of different providers and practitioners where I don't have to tap into my physiology knowledge or strength and conditioning or physiotherapy, like prehab type things. So I'm very fortunate where I can engage a performance team. So as a biomech, I can do a lot of measurement, but it's how do you make impact or have effective change into an athlete's performance or return from injury. And that's where working with a team is so critical. So I heavily rely on some of the knowledge of S&Cs and how we integrate certain things into their program, physiotherapists from prehab exercises to how do we work together to track towards their rehabilitation program as they're returning from injury. Physiologists in terms of how that whole engine works and how you then add in the mechanics side of it. And also acquisition is sort of a key one as well, where being able to have that change and doing can be quite critical because not every athlete responds to the same stimulus in the same way or the same cue or the same technical change or the same drill. So it's how do you work out what best fits that athlete, and that's where working with that team is so critical. If I was probably not in National Institute system, I'd probably have to tap into those skill sets a little bit more, which I like being just a biomech and being able to consult with the experts in that field, which is quite handy. I do tap into the PA element a little bit, particularly during performance analysis. So during major championships, where sometimes you're not doing the pure biomechanics, pure measurement, but it's more about how you're capturing the video, effective feedback for coaches and streamlining processes, which is quite critical. But yeah, without engineers from a coding perspective or building specific resources and tools for us, it wouldn't make some of our jobs functional. So I'm very fortunate that I do work quite closely with the performance team, and also in my national lead role, I get to work with my other biomechs in the network where we can work as a team to create effective change for our athletes and coaches, look at how we can streamline things, work collegiately together and, evolving some of our systems and practices and challenging ourselves. And it's very fortunate to be able to do that. I'm not sure where I'd be without that network, because sometimes you definitely need to bounce different ideas around, but also from a leads perspective, I'm very fortunate that I get to work with our other national leads with Athletics Australia. So we have a national lead for physiology, physiotherapy, athlete wellbeing and engagement, so nutrition. So being able to tap into them and their expertise, or linking us in with others, we wouldn't be able to probably work so collegiately together to make those changes for those athletes. So sometimes you just don't know what you don't know, and it's quite handy being able to tap into someone, or turn around at work and there's a person sitting behind you with a completely different skill set that can contribute something and get you to think outside the box, which is great. So, yeah.
Yeah, amazing. That's a really unique position. And so I guess your complementary skill sets, rather than being the other branches of sports science, is more in things like communication and even management as you're working with other people. So that's awesome. Thank you for sharing that.
Yeah, that's great. Great question. So, I mean, obviously it was the hottest Olympics in the history of the Olympiad. So, heat was a really important thing, or heat strategy. So obviously, consulting to physiologists and heat strategists, we have a really good guy, Mitch Henderson, who runs our end stage rehab, but he's sort of doing a PhD in heat, and there were some really good people, Joe Miller at the AIS, and formulating all these strategies. So that was obviously probably the evolution of sports science. And I think physically prepared wise, we did really well in that area leading into Tokyo. Obviously in other sports, you could see the effect that the heat had on marathon runners. So, the sports science in that space, but day-to-day stuff, more functionality around GPS technology. So measuring loads, and it's probably not a injury prevention or a performance measurement. It's probably a performance enhancement tool that we try to use to increase the intensity of training and make sure that we're in our football drills getting the required stimulus to prepare them for sevens. So GPS is the big one, and then measuring those running metrics within that to help coaches and implement what they want to get out of a session, but also physically prepare the girls. So we're really fortunate. Rugby Australia, Dean Benton and John Pryor and a few guys have really helped evolve the use of GPS. And then sports science-wise in the gym, just the use of technology, whether it be gym aware, jump platforms, speed gates, just to make training more competitive and measurable. So we sort of try and avoid having anything discretionary and really get the girls to compete and push the limits. And that's probably, from my experience when I played, 15 years ago, that's probably been the big evolution around how you can measure everything and then use that measurable to make it more competitive and give live feedback and real-time feedback. And then they can either self-correct or you can actually give them coaching cues to help correct and chase those numbers. So that's probably been the big thing around sports science. In terms of load management, we've obviously got Smarter Base, which we do with all our platform for wellness and screenings and all of the above. But we're sort of really trying to use technology now to drive a performance edge, as opposed to just assessing load or assessing wellness or well-being.
That's really interesting. So are you finding that you're borrowing and learning from established sports that might have been doing this a little bit longer than rugby sevens, or are you guys kind of forging your own paths here because it's such a unique sport with such unique demands?
Yeah, I think everyone's now trying to get that competitive advantage. I think we've the World Series has been around 8 or 9 years now, and so you get some pretty good retrospective data around trends in the game and the way it's going. So most of the teams, or the tier one nations per se, we can categorise them as on the World Series, would be using that type of technology. So you're definitely trying to use a cutting edge to provide an environment where you can do more football drills, or the coaches can do more football skills, but we can still get improvement in athletic qualities, and that's probably where we're going. As I said earlier, I'm fortunate at Rugby Australia that there's some really good coaches and mentors that help us out with that. but then it's also dependent upon how the coach wants to play as well. So you're sort of trying to tie in where you think the game's going, what your group's capable of, and then how does the coach want to play. And that makes it challenging, and certainly trying to get the right balance of both. You know, you want to live on the edge and you want to consistently push boundaries, but also having your best players available and fit and healthy helps as well. So that's where, you know, you sort of, it's a bit of a push-pull, and sometimes you get it right, and other times perhaps, you know, you learn from those mistakes in the past. So in terms of looking outside of our sports, you're always looking for other sports to see how they do things. Can you do it better? But per se, probably for female sports, particularly the rugby or collision sports, I should say, there's not that much retrospective data around time motion analysis, all of those things. So my PhD is interested in looking in that, and because I think trying to integrate the theory to the practical application is really important. And be able to tell a story around how these sports grown and I suppose how far the girls have come, both from an athletic perspective and skill wise. So, you know, there's some really good things I think that could be, you know, parts of that story that can be told.
So the clinical aspect, which is, you know, the physio derived stuff, is the core component of what I use. When I finished the PhD, I went and did a computer science degree as well, because I realized once I started kind of dipping into the world of biomechanics, it is kind of heavily sort of data driven. And I was the kid in year 12 that was thinking more about what I was doing on the weekend rather than paying attention when they were doing calculus. So I sat through sort of lots of meetings with people, because all I really wanted was code that was going to help me sort of strip out the data in a sort of a quick and easy manner. And I knew exactly what I was sort of looking at from the clinical aspect, and just couldn't really find enough help to be able to do that. So in the end, just decided I was just going to go and learn how to go and code it all myself. So it's probably a good thing in the long run. But yeah, the probably, apart from the classic biomechanical stuff, it was really obviously the clinical stuff, and then the data science component. Because I think if having an understanding of not only making it efficient in terms of pulling out the data, but then obviously utilizing it is probably the two bits that probably helped me the most.
Yeah, so biomechanics is kind of like the baseline skill set. My probably trade that I learned, I came from strength and conditioning and coaching, so sport coaching. And the premise of sport coaching is really built upon skill acquisition and motor learning principles. So I probably took for granted that I had that real baseline from my coaching experience in the past. I brought that in to my learned skill set in biomechanics, and I've really merged those. It wasn't until later reflecting that I had been merging those without intent. And it seemed really common for me to understand, oh, okay, this is just the measurement side, but this is how you would change this if you wanted to change something about someone's a technique or change the way they learn something. And so as I watched other people explain or go about their research, I realized I was coming about it from a slightly different approach. And that was just from my natural kind of skill set coming into biomechanics. So with that, I then started to realize the importance of probably data science and statistical skills. I mean, inherent to biomechanics is that our discipline probably captures the most quantity of data. So if you count it by bits, right? And so it's inherent that you have to have some computer science or data science skills just to harness that data, organize it, structure it. So again, you say you have the skill set in biomechanics, but you couldn't have that skill set in biomechanics without being able to structure, organize, and then analyze your data. So I think every biomechanist starts going into some computer science skills. So that's obviously programming. Some of us go into Python, some in R, some in MATLAB, sometimes across all of them, just because your collaborators work in one or the other. But once you learn one, well, it's a lot easier to, at least for a project, manipulate another one. So really, I'd say you should have an understanding of some experiential learning and skill acquisition and motor learning, because it's nice to measure something, but you only measure something because you want to change it. And you have to know how to change. And that's the important part for explaining why it matters, is that skill ac and motor learning aspect. The biomechanics is the base skill set, but to be able to use it, you really have to have this mixture of data science, computer science, which comes down to kind of programming or the programming languages. And then as we keep capturing more and more data, you see a lot of individuals being interested in challenging our traditional statistical approaches to testing hypotheses, right? And I think it's a constantly evolving and really exciting area. And it starts always linking back that your ability to take on some of these newer statistical approaches, or not newer, we're borrowing them from other sciences, to our data sets requires a little bit, at least, of programming language. So yeah, that's probably your three core skill sets. We'll call statistics, data science, and programming one. Biomechanics as how to do, and then how to change is really your skill ac and motor learning.
That's a really interesting crossover. I was just curious there when you mentioned about borrowing or the statistical side of things and taking statistics from other sciences. Is that, are you referring to there how a lot of traditional, looking at human sciences, we quite often look at large data sets with large amounts of participants, and so a lot of the statistics for those was developed around those massive numbers. And when you're working with particularly elite athletes, you're not going to get those kind of numbers. You're working with much smaller, sometimes single figure data sets. So is that what you were referring to there?
I think what we're doing is we're finding a way to do two different things really well. One is to zoom out when we have lots of humans and we want to see trends. And we're saying, okay, not every person fits to the mean. And we're all kind of starting to understand this, but there's still some groupings that we can learn from. And that's probably where we're borrowing from research like in metabolomics, where they have massive quantities of data. It's on lots of individuals, but they would move towards more of principal components analyses, right? Where they're like finding groupings within the data sets instead of one grouping around the mean, okay? So that's one approach when you have lots of people and you're like, well, I want to still make some generalizations, because it's really hard to say, well, every person's individual, because when you come back to coaching and actually explaining this to the people that'll use it with lots of athletes per se, you can't say coach every single person individually when you have 40 people on the pitch staring at you saying, what do I do, right? So I think that's our next best, to move away from the mean and borrowing some of our statistical analyses that are saying, okay, it's not just one mean, it's probably groupings within the group. So that might be one. The other one is to acknowledge that, yes, there is such a personalized prescription about individuals that if you wanted to, you could go from the zoom out to the zoom all the way in, and that's the individual analysis. And within that, that's probably moving towards looking at within person variability and understanding what someone's individual bandwidth is. And with that, I think that's where we're going away from taking one sample or one trial across lots of people, and instead looking at one person with lots of trials. And then that's a different type of analysis. So, you know, both are going away from the mean and explaining one thing for all people and saying we still need to make generalizations, but we still need to make an acknowledgement of the unique idiosyncrasies of a person. And I think we're trying to balance that. At the same time, we're trying to figure out how to explain that in a paper so that, you know, you're not overwhelmed. And I think moving forward, we'll be able to accept that your specific question should allow you to be directed in one direction or the other, acknowledging the limitation that you're not taking that direction. So when I think individual athlete analysis is one thing, we're going back to the case study and then kind of moving away from just broad generalizations and mean-based statistics, but that requires us to take a foray into some other types of statistical analyses, even non-linear analyses as well, which I haven't talked about, versus a more linear analyses approach that we've taken. But all of this means we need to know more. And it's a big task, particularly when you're early in your career, to go, oh my gosh, how could I possibly know all of this? And so it's just realizing no one knows all of it. It's just that you want to know more than you did yesterday, today.